This is section 2.2, part 3, where we're going to classify parallel and perpendicular lines. And you can see I've got an example of parallel and perpendicular lines drawn in our xy coordinate plane. Alright, so we got our x-axis here and our y-axis here. So go ahead and draw those down. And we can see parallel lines will go on forever in each direction, and they will never intersect. They will never touch each other. And I have that written down below. Alright, parallel lines will never intersect, and the reason they don't intersect is because they have exactly the same slope. Remember, slope is represented by the variable m. And that's why parallel lines will just always be next to each other and never intersect. Perpendicular lines, on the other hand, do intersect, but they intersect in a special way. Alright, their intersection point forms a right angle. So we can see that down here. Perpendicular lines intersect to form a right angle. And the reason they form a right angle is because they have opposite reciprocal slopes. Let me slide this over a little bit. They have opposite reciprocal slopes. So they have opposite signs. One's always going to be positive, one's going to be negative, and then they're also reciprocals of each other. So, if we're unsure of what reciprocal is, let's get a quick little review down here. Alright, I've got a little table drawn. So I've got example slopes here on the left-hand side. And on the right-hand side, we've got a spot for our opposite reciprocal slopes. So, if our slope is 5, opposite means we're always going to change the sign. Alright, so this is positive, so we know we're going to have a negative slope. And now the reciprocal of 5 is 1 over 5. Remember, reciprocal, you just flip the fraction. And any integer, whether it's positive or negative, will always be over 1. So that means the numerator in the reciprocal will be 1. Here again we have another integer. It's negative 3. The opposite reciprocal, since this number is negative, our opposite reciprocal slope will be positive, and it will be positive 1/3. Here, our slope is already in fraction form. It's negative 3/2, so the opposite reciprocal is positive 2/3. So it kind of gives you an idea of what the opposite reciprocal slope is. So if I were to graph two lines that had these slopes, each of the two lines would intersect to form a right angle, and it would look something like what we have pictured above. Okay, so now that we know a little bit about parallel and perpendicular lines, let's put our knowledge to use. And I've got a problem down here. We want to tell if the lines are parallel, perpendicular, or neither. So you're going to be given two different points for each line. Alright, so we've got two lines here. Line 1, we know line 1 is going to pass through the point 0, 2, and it's also going to pass through the point 1, 3. Line 2 is going to pass through the point 1, 0, and also pass through the point -2, -1. Or positive 2, -1. So, how do we tell if these lines are parallel to each other, perpendicular, or neither? The best way to do it is not to graph. Alright, because by graphing, sometimes it's hard to tell if the lines are, in fact, perpendicular to each other if they intersect. Alright, so the best way to find out is to find the slope of each line and then compare that slope. So we're going to find the slope for both line 1 and line 2. Alright, so we've got line 1 down here. We'll do line 2 over on the right side. And remember, the formula for slope is m equals y2 minus y1 over x2 minus x1. It's the change in y over the change in x. So for line 1, alright, we need to pick a starting point. So I'm going to start with this point. So I'm going to look at the y value, which is the second part of the ordered pair. So I've got 3 minus 2. And that's going to go over x2 minus x1. So remember, I started with this point, so I have to continue to start with it. So it's going to be 1 minus 0. So 3 minus 2 is 1. 1 minus 0 is 1. So line 1 has a slope of 1. Let's do the same thing for line 2. So we'll find m, our slope. We'll start with -1 over, -1 minus 0 over 2 minus 1. -1 minus 0 is -1. 2 minus 1 is +1. So we can see -1 divided by 1 is -1. So our last step will be to analyze these two. We want to say, are these the same? If they are, we would have parallel lines. But 1 and -1 aren't the same. So our next question is, are they opposite reciprocals? So I've got 1. So remember, m equals 1 is the same thing as 1 divided by 1. M equals -1 is the same thing as -1 divided by 1. So we've got opposites, and is 1 over 1 the reciprocal of 1 over 1? And it is, right? So we know, since they're opposite reciprocal slopes, that lines 1 and 2 are perpendicular. Remember, if the two slopes were exactly the same, we would write lines 1 and 2 are parallel. And if we had two slopes that were neither the same nor opposite reciprocals, we would simply write lines 1 and 2 are neither. That's it.